Welcome to YouTube with Lubelski. Today we will be focused on proportions in tables. Please follow step by step to do this video. Always lovely to have you.
Okay, welcome back with YouTube with Lubelski. Today we are going to work on proportion tables. So determining whether or not a table is proportional, which means there's a constant change throughout the entire table. Before we jump into this worksheet though, I am going to give you some notes. So if you have a notebook that you're keeping notes in, please make sure that you get that out real quick, and I am going to take a little note. So proportions and tables. What do? Well, proportions and tables, step one is to identify your X values and Y values. So which column or which row in your table is your X values and your Y values? Sometimes it'll say it right there, point blank. Other times you might have to label it so that you know which is which. Step two, use the ratio Y over X, which is equal to our K, constant of proportionality. So constant of proportionality. We're trying to prove that it's constantly moving at the same rate. All right, step three. Check every ratio in calculator. There may come times where you don't have a calculator, so you have to simplify the fraction into lowest terms to compare. But if you do have a calculator, which I do, I am going to go ahead and I'm going to just divide them out. Okay, so you take Y and you divide it by the X. So you're taking your Y over X ratio and you're going to take the Y and divide it. This fraction bar is actually like a division bar. So we're going to divide it by the X and see what is it equal. The key to this is you have to check every single one in the table. So we're going to do an example of that. So get back your packet and let's start with our first table. So first of all, we want to identify our X and our Y. We've got that. We are going to use K equals Y over X to check every single pair of X and Y coordinates. So let's go ahead and do that. My Y is on the bottom, so I'm going to put that on top though. So 2 over 1 equals 2. Then do my 6 over 3. 6 over 3 equals 2. Then the next one, 18 over 9 equals 2. And my last one, 10 over 5 equals 2. So if we look here, we've got a constant ratio of 2 times. I'm multiplying my X times 2 to get 2. 3 times 2, 6. 9 times 2, 18. And so there is a constant change there. So this, in this case, here is my proof because I did all the work. And yes, this is a proportional table because it has a constant rate of change. It's changing the same every time. It's multiplying by 2. So let's take a look at question number 2. We're going to do the exact same thing. We're going to do our Y over X. So 6 over 2. 6 divided by 2 in my calculator is 3. If you're not good at doing division in your head like that with numbers, then just go ahead and use your calculator, because sometimes you'll have negatives, sometimes you'll have decimals, sometimes there will be fractions involved. And yes, it's good for you to be able to do all those things, but if you have a resource like a calculator, it just makes it go a lot faster. So 12 over 4 is 3. 24 over 8 is 3. 21 divided by 6 is, in my calculator, 3.5. So, here's a new situation. 3.5. If it's different, that means that this is not proportional. The constant of y over x has to be the same across the entire table. Another way you can do this is you can also try and figure out 2 times what equals 6. Well, 2 times 3 equals 6. 4 times 3 equals 12. 8 times 3 is 24. 6 times 3 is 18. So if this were proportional, it would have to be 18, not 21. But it's not a proportional situation, so we just label it as not proportional. Question number 3. Now we've got some negative numbers. So in your calculator, you want to make sure that you are including those negatives, because if you don't include the negatives, then you might make mistakes on whether or not these are equal. So 9 divided by negative 3 in the calculator gives me negative 3. Negative 27 divided by 9 equals negative 3. 21 divided by negative 7 equals negative 3. And my last one, negative 15 divided by 5 equals negative 3. So here we've got negative 3, negative 3, negative 3, negative 3. There is a constant of proportionality across the entire table, so this is proportional. Question 4. Negative 8 over negative 2. The negatives cancel and I get 4. 4 divided by 1 equals 4. 12 divided by 3 equals 4. Negative 16 divided by negative 4, the negatives cancel and I get 4. So if all of my constants, or if all of my ratios of y over x equal the same thing, there's a constant of proportionality. And in this case, it's negative 2 times 4 is negative 8. 1 times 4 is 4. 3 times 4 is 12. Negative 4 times 4 is negative 16. All right, so there we have 4 examples of checking the table. And now what I want to do is just give you the answers so that you can compare your answers. Go ahead and practice on your own. Pause the video. Practice those last 4 tables on your own, and I'm going to give you the answers at the end of this video. When I do y over x for number 5 for all of the points, I get that this is non-proportional. When I do it for 6, y over x, this is also not proportional. Seven and 8, if I do y over x for 7 and 8 using the numbers in the table, I get proportional for 7 and proportional for 8. Again, you should be doing the y over x for all of these, but because it's the same process in every single table, I gave you 4 solid examples of how you should do it. You should have replicated that on 5 through 8, and then there is more additional practice that will use this exact same technique.